All right, here we go. All right, now for inverses. All right, there's lots of reasons why inverses are important, but we're not going to go into the detail. All right, the inverse. Let me ask you this. This is a good example. Does everybody understand there's a formula to convert Fahrenheit to Celsius, correct?
Yeah.
Yeah.
Right, so you would say F equals like 9/5 something, right? Thank you. If there is Fahrenheit to Celsius, then there's also what? Celsius to Fahrenheit. Those are called inverses of each other. All right, those are called inverses of each other. All right, so what I want to do is I want to show you how Fahrenheit can relate to Celsius and Celsius can relate to Fahrenheit. All right. So when we talk about inverses, literally, this is all we're doing. All right, when you talk about inverses, all right, when we say addition, I say, what's the inverse of addition?
Subtraction.
Subtraction. Same thing with multiplication, division. Square and square root.
I'm having trouble noting it. It's sending me like
So what am I supposed to do? Stop class to help you.
I'll just go down.
Right, thank you. Remember, in here, I'm trying to teach you, take care of your own responsibility, personal responsibility. All right? So now, inverses. All right? Inverse literally means all you're doing is switching the x and the y. All right? That's all you're doing. All right? So to find the inverse, you are switching the x and the y. All right, so here we go with number one, right here. If I want to find the inverse of this relation, see where it says 4, 7?
Yeah.
What's the inverse?
74.
Wow. And yet every time on the test, I'm going to have people mess that up. I don't know how. I have no idea. All right, so the inverse would be, this is 7, 4. This would be what?
2, 6.
2, 6. This would be
-1, 9.
-1, 9. This would be
11, 311.
3, 11. That is the inverse. All right, that's the inverse. Literally, all we're doing is we're switching the x and the y. So if I'm asking you about number 2, all right, here we go. Number 2. -9, comma, -5. Next point. -6, -4.
-4, -2.
And then
And then
-3.
-3 comes in.
-3, comma 0. That's the inverse. Yep, I'm agreeing with you. Very simple. All right. So here we go. I'm going to look at number 3. So this is a list of ordered pairs. This over here would be a what? This would be called a table. Everybody with me on that?
Yeah.
That'd be called a table. All right. So now all I have to do is switch the what?
X and Y.
You just have to switch the x and the y. All right. So I am really lazy. So I'm going to try to figure out a way to do what? Copy and paste. So here we go. Let me see if we can figure this out, guys.
Don't put the X in the Y.
Here we go. Copy, paste. And now, the grand finale. I've just created the what?
Inverse.
Just created the inverse. Anybody have any issues with that? Uh-oh, some of you looking at me like I'm crazy. How did I do that?
Oh, no, I have to.
Do we agree? The x becomes the what? The x becomes the y, and the y becomes the what? The x. Now, some of you are like, can I do it this way? I was just thinking about this. I could just copy the whole thing, paste the whole thing, right? Shrink it down a little bit, crop it a little bit. Oh, no, I can't do that.
Just write it out.
Or we could just not be lazy, right? Just write it out. All right, you have a choice.
Isn't that what technology is?
Don't hit that and then have.
You could
I like
just,
the
you
accent
can write it out and
line.
then color it over in white and then move it into the.
Yeah, that's true.
Wait,
No,
why
because
is
you
that?
can't place on top of whiteout.
No, if you copy the
Oh,
writing
yeah, I
over
know what you're
outside.
saying. Yes, you can. All right.
We're just
Yeah.
finding ways to be
That's how, listen, that's how a lot, believe it or not, that's how I write your test. I just copy and paste and just change the numbers around. All right, it's very easy. Very, very easy.
I'm gonna take your.
All right, what?
Can you just like change the.
Then I was thinking about this. I was thinking, well, why wouldn't I just do that? If that's the case, why wouldn't I just come over here and wipe this out? Right, and then wipe this out. And then come over here, change, this is now my y, and this is what? That's my x. All right, I like that idea too. All right. But again, listen, it's kind of funny, all right? But again, that's all there is for the inverse, is switching the x and y. All right, that's all there is for switching the x and y. Now, for some reason, I don't understand again why, but now we're gonna have to graph the inverse. We're gonna graph the inverse. So I'd like everybody to really kind of pay attention here on question number 6 for me. All right, I am graphing the inverse. I'm graphing the inverse. All right, so what do we do when we graph the inverse? Just what?
Of course.
Yeah, we can plot some points, but we have to find what points. Right, so what I want to do is I want you to take, all you have to do is find 2 points that are on the line. Right now, this point sticks out to me right here.
Yep.
And then this point sticks out to me right here, right? Sorry. I just looked at those 2 points, correct?
Sure.
So now I want you to tell me what are those 2 points. The first y-intercept is
0,
0,
6.
0, 6, right?
Oh.
0, 6 is
Yeah,
counting by
twos.
2s. So if 0, 6 is the point on the graph, then the point on the inverse would be what?
0, negative 6.
4.
Wait a minute,
6,
come
0,
on
6,
now.
0.
You just told me 0, 6 is on the graph, so then
6, 0.
6, 0. So now we plot 6, 0. And what's the other point that's on the graph?
6, 4.
6, 4, thank you. So if 6, 4 is on the graph, then
4, 6.
4, 6.
4, 6. So now you plot the point 4, 6.
The graph is 4, 6.
Wait a minute.
No, 6. Alright, okay.
So now if you are confused, just write 0, 6 and write 6, 4. Those are 2 points on the graph, right? So now the inverse would be what? 6, 0 and 4, 6. Is everybody with me on this?
Yeah.
So now we plotted those points, and now you just graph the line, or draw the line, whatever you want to do. There we go. That would be the graph of the inverse. That'd be the graph of the inverse. Now, something that you will know later on that I always like to show kids, even though it's not going to be tested, is whenever you graph the inverse, we say it's symmetric over the line y equals x. So I'm going to draw y equals x now, guys. All right, so if I graph y equals x, it is going to start at the origin with a slope of 1, and it's going to go up through here, and down through here. And what you're supposed to realize is that they are symmetrical. In other words, if I were to take the original line and the new line, and if I fold it on that line, then the other line appears. All right? The other line appears. What?
Does the line always go like diagonal through 0?
The y equals x does, yes. Right? So I'm trying to show you if I were to measure this now, again, it's not really a big deal. I don't know why I'm spending time on it. But look, if I were to measure here is 1.5. So if I do 1.5, guess what? It's dead on right there. That's what is meant by symmetrical. All right. Any point on this line is symmetrical about the line y equals x. So when you graph a function and its inverse, it's symmetrical about the line y equals x. This equation right here is called y equals x. All right, that's just some information. All right, so let's try to graph that for number 7. All right, so again, everybody try to find 2 points. All right, then you can see if you match up with my points. So I'm thinking this point right here. I'm thinking this point right here. So I'm looking at 2 points and I'm calling them what? Somebody.
-2, 6.
-2, 6. And the other point
And
was,
the other point was
-4,
-4,
-6.
-6.
okay, -4, -6. Again, I don't think it's that hard. Identify 2 points. All right, now what we're going to do is we're going to say, okay, let's graph the inverse. Let's graph the inverse. So the 2 points that are inverse would be what?
Negative
6, -2.
6,
And
comma,
then
-2,
-6, -4.
and -6, comma, -4. Reagan, you okay with this? All right. Mr. Caruso, we're just doing inverses, switching x and y.
Okay.
All right, now I'm graphing the point 6, -2. And I'm graphing the point -6, -4. Then I'm drawing that line. Now do me a favor, just because I want you to be smart. We're all going to graph y equals x. Now to graph y equals x, it starts at the origin and just goes right down the middle of the graph. When it goes right down the middle of the graph, this one I think is easier to see the symmetry. And what I'm trying to show you is I'm demonstrating this right here. When I reflect it over that orange line, it becomes this. Everybody see that?
Oh,
Right? The orange, if I reflect it over the highlighted orange, if I reflect it over the orange line, it becomes the highlighted yellow or green or whatever you think that is. All right, that's just the symmetry.
How do you like make that a problem?
What do you mean?
I get that, but like I don't get
What's the point?
what the point.
Is that what you're asking?
Oh,
me?
I see. Okay.
All right. Okay, so let's do,
-4, right? -4, -4.
say it again.
Wouldn't it be -4, -4? For that.
All right, look at number 8. All right, let's find 2 points that are on the graph. What 2 points? What?
8, 4, 0, -2.
Somebody says 8, 4, and what?
0, -2.
0, -2. What's the matter? Tell me.
oh, okay. I just did 8, -8.
8, -8 would be right here.
I mean, -8, -8.
-8, -8. And sometimes it is good to do 3 points because then you know whether or not you made a mistake. All right? But go to 8, 4, and now 8, 4, what would be the
4, 8.
inverse of 8, 4?
4, 8,
4, 8, and then what?
2, 0.
Then what?
-2, 0.
And then what? Yeah,
How do
-8,
you- how do
-8.
you-
All right. So -8 obviously stays. Then 4, 8. And then -2, 0. And if you try to draw that line, do all those points line up?
Yeah.
Yep, easy as that. Now, once again, let's just for our own fun draw y equals x. Just so you can see, in fact, it is symmetric. Hopefully you can see that a little better too. What?
How do you know if it's symmetrical or not?
I'm telling you it always is on all inverses. All inverses are symmetric around the line y equals x. When you get to Algebra 2, pre-calculus, they'll teach you more about exactly why. All right, but right now, that's just something I'm showing you. It's the mirror image. Come on, guys, that was easy, right? All right, so here we go. The next lesson, 1, 2, 3, 4, 5, 6. Now, we have to find the equation of the inverse. Or we have to find the equation of the inverse. So who can tell me what does f of x mean? And don't tell me f times x.
Is it the y-intercept?
It is the y value. It is not the y-intercept, it's just the y value. What's the matter?
Oh, I was just saying, do we just make the positives negative, x and y?
Now remember, we didn't make them positives and negatives.
We flip them.
Yes, you flip them. So I want everybody to write under f of x, I want everybody to write y equals 4x minus 3. And as Sean stated, we are literally switching x and y. So what does the y become?
X.
X equals 4 what?
Y.
Y minus 3. All right, now that is the correct equation for the inverse. All right, but they want you to always write the inverse in y equals mx plus b form. So what do I have to do with minus 3?
Add plus 3.
Add 3. So now you're going to say x plus 3 equals 4y. Now what do I do?
Switch the y.
No, what do I do?
Divide by.
Divide by
4.
4. Now watch me divide by 4, guys. Divide by 4. Divide the whole quantity by 4. You can leave it like that. So now the inverse is y equals x plus 3 all over 4. That's the inverse. Now in math, we have a symbol for inverse. I always tell kids I don't like the symbol, all right? But here is the inverse symbol. I want everybody to write this. F -1. When something is raised to the -1 power, it is the symbol for inverse. I don't know why. All right, so we're going to say f -1 of x is equal to x plus 3 over 4. That is the symbol for inverse. That's why people, I think sometimes when they look at math, they think it's complicated. All right, f -1 of x, what in the world does that mean? That just means that is the inverse. All right, that's the inverse of the original function. All right, that is the inverse of this function. All right, here we go. Let's look at number 2. That's the answer.
Yeah.
All right, here we go. On number 2. So where f of x, I'm just going to replace f of x with what?
Y.
Y. So I want everybody to write y equals -3x plus 7. And then what do I want you to do?
So, x equals.
X equals
Negative 3y plus 7.
-3y plus 7. Everybody good with this?
Yeah.
Now we're solving for y. So when I solve for y, I have to move the 7 over to the left, and that becomes
Minus
x minus 7 equals -3y. Now what?
divide by -3.
Yep, divide by -3. Divide by -3. So now we're going to come up here, and we're going to say f -1 of x is equal to x minus 7 over -3. Really, really, really simple. Really simple.
You already put y and then put f in there.
Yep. I don't care how you do it. All right. I just want you to know the symbolism for inverse. All right, here we go, number 3. So now, instead of writing y equals, I can just rewrite this now that you understand that. F of x, instead of putting y, I'm just gonna put what?
Perfect.
X, right, because I know that's true now. X equals 3/2 what?
One.
Y minus 8. So now what do I have to do?
Add 8.
Add 8. X plus 8 equals 3/2 y. How do you undo a fraction?
Multiply with
Multiply by the reciprocal. So y equals, what's the reciprocal?
2.
2/3. Parentheses. 2/3 what?
X plus 8.
X plus 8. All right, come on now. So now we're going to write it as f -1 of x is
equal to
2/3 times x plus 8. All right, that's it. Simple, simple, simple. All right. Now here we go. Let's see how you're doing on number 4. All right, so automatically I'm just going to change f of x to what?
X.
X equals 16 minus 1/3 what?
Y.
Y.
Oh,
Now, come on, guys. Come on now. If you don't know or you're having trouble, you're trying to save the work now. Just writing my information is pointless. And I'm talking to those of you guys who want to do better. All right? Speak up. If you don't know something, now's the time to ask. All right? I mean it. You can't do better if you don't try. Trying is not just writing the things down that I'm saying. I'm working backwards now. So what do I have to move?
16.
I'm moving the 16. It is what on the right side?
Positive.
Positive 16.
so X.
So on the left side, it's going to be
Minus 6.
x minus 16 equals negative 1/3 y. Now I keep telling you over and over, to handle a fraction, you what? Multiply by the reciprocal.
3.
What is the reciprocal? Be
Negative
careful.
Negative.
-3, open parentheses. X minus 16 equals y. And then we're just going to write f -1 x equals -3 parentheses x minus 16. Now, honestly, if you just said that to someone, you look like really smart. It looks complicated. Right? That's the problem with a lot of math. It looks complicated. Right? And if you don't pay attention to the notation, you can't understand math. What?
So when you move it, you just change the sign to positive to negative and negative to positive.
Wow.
Okay.
All right, here we go. Number 5. X equals 3 parentheses y minus 5. Now, what can I do first?
Distribute.
You can distribute,
Add
or you could just say, hey, I can just divide by 3. If you distribute, is that wrong? No, it's just going to take you, in my opinion, an extra step. So I'm dividing by 3. I personally would prefer the fraction 1/3. You can put x divided by 3 if you want. I think it looks better if you say 1/3 x equals y minus 5. Now what? Add 5. So y equals 1/3 x what?
Or plus.
Plus, which one? Are you just going to say both of them today?
Plus 5.
Plus 5. All right? So now, y is the same as f -1 of x equals 1/3 x plus 5. That's the inverse. All right, one more. All right, simple, simple, simple. Okay, so f of x becomes what?
Well, or, yeah,
X.
X.
X equals,
Negative 15 minus 2/5.
Why?
Y.
beautiful. All right, come on now. What do I do?
Plus 15.
Add 15. So again, x plus 15 equals negative 2/5 y. Now it requires a what?
You multiply by the reciprocal.
Reciprocal. It requires a reciprocal. So we say y equals, what is the reciprocal?
Negative
5 over, negative 5 over 2.
Yeah.
Negative 5 over 2. Open parentheses. X plus 15. So now f negative 1 x equals negative 5 halves parentheses x plus 15. Now hold up. I'm just saying now, take a breath, and if anybody in here says, okay, look, man, I daydreamed for a minute and I missed a problem, and could you just explain this one more time? Right, that's what I'm interested in right now. What?
So I got it, I was just confused.
No, that's not what I'm asking. Just tell me what number you'd like me to review.
On number 5, I'm confused on how you got 1/3.
What's the reciprocal of 3?
Never mind. Okay.
Right? 1/3.
Yeah, I was.
William, what? It's okay. Hunter, everything is good, man.
I-
This is what you're responsible for. I don't want you to be scared to ask me a question. Right? I want you to be tough. Say, look, man, for some reason, I just missed a step. Just tell me what the step is, and then we move forward.
Yeah, I
All right.
was just missing that.
Go, William.
For 7, like,
For 7, like.
no, I mean, like, it's like a small question. Like, how do you know if you use parentheses or not in the final?
If you're multiplying by a quantity or you're dividing by a quantity, that means you need parentheses. What does that mean, William? Look up. If I say to you 3x equals 7, I don't need parentheses because there's nothing with the 7. If I say 7 plus y and I'm dividing by 3, I'm dividing this quantity by 3. I'm not just dividing 7 by 3 or y by 3. I'm dividing that whole quantity by 3. So in other words, if there's addition or subtraction involved, when you're doing multiplication or division, it requires parentheses because you're doing it to that quantity, not to the individual pieces. Are you with me?
Yeah.
All right, now listen, guys. I want to make sure everybody understands what I'm saying, right? Does everybody hear me? I want to help, right? And I'm frustrated with some of you because you just don't let me help. And you make up some lame excuses like I would care about your excuse. I don't care about excuses, right? You don't have to just tell me what the problem is so I can help you, all right? And again, some of you just need to work. That's nothing beats experience. All right, nothing beats experience. You're supposed to make a bunch of mistakes. All right, that's why we do all the problems and then we take a test. All right, because you did all the mistakes. Now you've corrected them. All right, now you're smarter. All right, but if you don't do the homework, if you don't do the practice, it's so easy for me to tell. When I sit down with your parents, that's the first thing I say. I know they're not doing their work. You're not ever fooling me. Ever. You're not getting away with anything. I promise. All right? I want you smarter. I want you to be happy with yourself when you go to high school and you sit in your math class and you go, wow, this is good. All right? That's what I'm interested in. All right? You've got to tell me if there's a problem. I don't want to go to your parents and say, look, there's a big problem here. All right? Something's not working. All right? We got lots of time to change. You've got lots of time to correct whatever the problem is. All right? It's only, like I said, November. November's a short month. December's a short month. All right? So you've got to do good on the next test, which is when?
Friday.
Friday.
This Friday?
No.
Yes, this Friday. Tomorrow, we're having a big test. All right, Austin?
Is that a test?
Go home and study. Shh, no one's talking to you. All right? Now, the next part. Some of you probably are already done with the homework. Next page. Do it all. Exactly what we did. If you having issues, look at your notes. All right? And if you're, if you're a glutton for punishment, go watch the video again. Right?
That's good.
Yes, I know. All right. Anybody have any issues? Not personal. Or I'm talking about math.
Well,
All right. William.
It's like about math, but it's also kind of personal.
All right. Well, I don't want to hear the personal stuff right now. All right. Get the homework done, guys. Get the homework done. All right.
Mr. Shaw.
All right, Xavier. See you tomorrow, buddy. Get your work done.
Downstairs for this part, how would you do it? Is it
Uh,
just the calculator stuff or?
No, switch the X and Y. That's what we're doing. Switching the X and Y. All right. Here, I'll let you borrow my iPad. You can go back and see what we did.
Oh,
Go sit down. Take it with you.
okay.
What?
I get it.
Wow.
Connor getting something?
All right.
He knows,
In
he knows.
meeting. No one's talking to any.